Hi, I'm going to demonstrate some SQL statements that I've written that use aggregate functions and a couple of clauses that we haven't looked at yet, one being the group by clause, the other being the having clause. So I've written these queries, tested them in advance, and have them stored in a text file, and I'll just be copying and pasting from the text file into the query editor, so this should go quickly. As we look at the first query to be demonstrated, there's really nothing new here. It's performing an inner join between the employee table and the job table, and the select statement contains a aggregate function, the count function, and I'm going to be counting the number of rows as I look down the employee ID column in the results set. And so since every employee has a job, and we'll take a look at the table here in a moment and verify that, but since every employee has a job, then I would anticipate the value that is output to be equal to the number of rows in the employee table. So highlighting that, I'll execute a Control-C and then work my way over to Visual Studio, or to Management Studio, and you'll notice that I have the HR SQL2 database attached, as well as the Northwind Convert database. I'll be using both of these databases here in the process of demonstrating. If I look in the employee table, and let's take a peek at the records in the employee table before I execute the query, and look down the job ID column. Okay, so this is the foreign key field in this table. You notice that there is a foreign key value for every employee. There's not a value of null, which would indicate that all 8 employees, you can count them, all 8 employees have some type of job. Okay, they point to some row in the job table. So when I execute the query, I'm going to click on the New Query button. I mentioned this in class, but I'll mention it again for the benefit of anyone that might not have heard me. When you execute a query, then the database management system is going to attempt to use one of the installed databases. Sometimes it's the one you want, sometimes it's not, so you might want to check to make sure that it is in fact using the correct database. Okay, so in this case it is. When I tested this a moment ago, it was not, so just bringing that to your attention. So I'll paste the SQL statement into the query editor and execute, and as I expected, it returns a value of 8. So that could be meaningful information, but you know, there are some other things that I can do with aggregate functions that make them even more useful, and we'll take a look at what that is. Now I'll just leave this query window open and continue to go back to it and paste in different queries. So the next example is going to execute this code, and what you see then is in the select statement I'm going to be projecting 2 columns. The first column is going to be counting the number of employee IDs, and it's going to be looking down the employee column. The second column that's output is going to be a job description. Okay, so I'm doing an inner join between the job and the employee table, so both of these columns are available in my results set. And what's different about this is that it also uses a group by clause. Okay, so that is appended to the end of the statement, and it's going to be then grouping the result set by job description, okay, which happens to be, and in order to use this group by clause, must occur as a field in the select statement. So it occurs as a field in the select statement, and what it's going to do then is it's going to, as the name suggests, it's going to group my output by job description. So if I have 5 different jobs, there's going to be within the results set a subset perhaps for a job description faculty and a corresponding count of the records in the result set that correspond with faculty. That might be followed by a grouping of output within that result set of jobs that have a job description of administrator, and then a corresponding number of rows that correspond with administrators. So I'm going to get a count of each category. And when I execute a Control-C on this and go back to my query editor and execute, you'll see that I get groupings, and one of the job descriptions among records that appear in the result set that occurs when I perform an inner join on the job and employee table would be faculty, and 6 of the rows in the result set relate to rows where the job description column is faculty, and then there's 2 other categories. Okay, so hopefully that makes sense. I'll let you look at it for just a second. All right, so moving on, I'm going to introduce another clause. So I append another clause that supports the group by clause that allows some additional selection among records that are affected by the group by clause. And so I'm going to be using the having clause. So let me go ahead and copy this over to the query editor. And analyze what's going on. So I'm going to be projecting the same 2 columns. I'll be performing the same kind of join operation between the job and the employee table. I'll be grouping by job description. Again, I can group by job description because job description is one of the fields that I'm projecting. And then among those records, I'm going to only display the ones where the employee ID count is greater than 4. So if there's a grouping where, and there was, if you recall from the previous result set, where the number of rows within a group is less than 5, then they won't appear in the output. Execute the query, and the only one that executes is the row for faculty. And I'm going to take that out again, execute it one more time, and you'll see that I had previously eliminated these 2 rows because the count was less than 5. Okay, so hopefully that makes sense. Again, using the having clause to further support the group by clause and do some additional row selection. So the next query that I'm going to do, and incidentally, these statements that I put up here, you probably guessed it already, are just comments, and I'm using the hyphen, hyphen, dash, dash, whatever you want to call it, notation here, which is what trans SQL, the type of SQL that we are very soon going to be working with, this is how you make comment statements in trans SQL with hyphen, hyphen. So as opposed to a C-based language where we might put slash, slash, hyphen, hyphen is the notation. Okay, so looking at the next query, let's see what it's going to do. Going to be projecting the same columns, okay, and it's going to be performing an inner join on the same two tables, so that much is consistent with what we saw in the past. It's going to be grouping by job description. We know what that's all about. And I've added two additional clauses. Okay, so an order by clause, which you're already familiar with, that's how we sort. And then the having clause, which you saw previously, which is going to do some row selection. But this time, rather than the having clause, using a aggregate function, the aggregate or the having clause is going to reference a field that's being used in the group by clause. So that having clause can base selection on two different things, either a direct reference to an aggregate function, or it can make reference to whatever field is being used in the group by clause. And in this case, I'm going to be selecting only output that begins with F. Okay, so I'm going to use the like operator and a wildcard. So let's see how this looks. Now, I should have pointed this out a little bit earlier in the video, but now is as good a time as any. I had mentioned probably last week, I think it was, that you cannot use aggregate functions in a where clause. Okay, so normally we'd use a where clause to perform row selection in a normal query that involves a select statement. So if we want to create row selection and we want to base that row selection on either directly or indirectly on a aggregate function, then you're going to have to use the having clause. So the having clause and where clause have, some similarity in that they both are doing row selection. Okay, so I'll go ahead and paste this in. Let's see what it does. And it should return two rows then, because faculty begins with F and freeloader begins with F. And if I execute, I get those two rows. And I order by employee account of employee ID, and I order in ascending order. So the default for this is ascending order. So I guess this is a little bit different than what we have seen before with the order by clause too. Before I had specified just a column in the result set and had an order based on whatever the column values were. In this case, I'm ordering by this derived field, so that's not actually even a field in the stored data, but I can order based on the value that I get from counting the number of records down a column. Okay, so the last thing I'll do there is go ahead and change that to DESC, I think is the keyword, and execute and flip the order, okay, by listing them in descending order as opposed to ascending order, okay? All right, hopefully that makes sense, and let's take a look at the next one. Okay, so the next one is going to access data in the Northwind database. So I'm going to have to change databases here. Okay, so here's a case where I'm about to execute a query and it still is kind of stuck on the HRSQL2 database. If I go ahead and paste into the query editor, it's going to put squiggly lines under all these fields, not recognizing any of those tables, any of those columns, until I switch over to the correct database, and then the squigglies go away. So let's analyze what's going on in this query. So I'm going to be projecting two columns, category name and then a derived column, which is going to be the sum of the units in stock. Okay. Now, for this to make sense, let me very quickly here go to the database diagram and point out something. Okay, so I have a lot of tables. Okay, I need to push some of these tables out of the way so you can see more clearly that there is a one-to-many relationship between the products and categories tables. Okay, so with the categories table being the parent table. And logically, what we have are row after row of products. Okay, so those are individual products that have a name, have a unit price, have a units in stock, have a order point value associated with them. And every one of those products then will relate back to some category. Okay, so I have, maybe Pepsi as a product on row 57. It's going to relate back to maybe row 1 in the categories table, which would be a row that contains data related to the category beverages. Okay, so you've seen this before. I'm just calling this to your attention so that if you got a, kind of a fresh perspective on things before we get into the details of the SQL. Okay, so I think that's everything I need to point out regarding the data that we're working with. I will point out one other thing. In the categories table, I think, and we'll check here, that there are some categories that I've added where there are no products. Okay, so I've got some additional categories. Maybe I'm planning on selling some new products, so I go ahead and populate some additional rows in the categories table in preparation for that, but I haven't really received any of the products, and I don't have anything sitting in the warehouse. So it would be possible to have parent records without child records, and that's a fairly common occurrence. You've seen that played out with the employee and the dependent table, for instance, in the HRSQL2 database. So that may affect things. Okay, so in the output, let's see what happens here. I have shifted things around, and it thinks that I've made some kind of real significant change to the database diagram. I'm going to respond with no. And now if I execute the query against the Northwind database, what should it do? It should provide me with a grouping of category names, and for every category name it's going to give me the sum total of units in stock. So when it does this inner join between the products and categories table, it's going to look down the units in stock column for a distinct category name, and it's going to sum up the units in stock. So if I have 3 products within a category, and the first product has 10 units in stock, the second product has 20 units in stock, and the third product has 10 units in stock, then I would anticipate whatever category that relates to appear as the category name alongside a value of 40. And then it would go on to the next category. So hopefully all that makes sense. And when I execute, I see that there are category names appearing with a numeric value that results from summing all the products within that category. Okay, so that's how many things I can count on a shelf somewhere in a warehouse that relates back to condiments. And I'm also seeing some values of 0 down here, and that would be indicative of these categories that have been put into the category table where there is no corresponding product. Okay. Or it could be also reflective of categories where I have sold out all the items in stock. Okay, so I would need to do some further investigation in the warehouse to determine exactly what those 0 values are suggesting. All right, so done with that one. Hope that makes sense. And I think the next query is going to eliminate these rows at the bottom beginning with junk food that have values of 0. Let's see whether that is in fact the case. And let's see. No, it's not. Okay, I'm getting ahead of myself, I think. Okay, so in this one, it's going to be a little bit different, a little bit more interesting, actually. So let me go ahead and copy it into the query editor. Take a look at what it's doing. I'm going to be outputting 2 columns from the same 2 tables involved in an inner join, except this second column is not counting values down a column. It's actually doing a calculation between 2 columns. So what it's going to give me is not a count of the actual physical items on the shelf, but the value of those physical items. So for every row that's involved in the grouping, it's going to be multiplying the sum total units in stock times the unit price associated with them. So again, I'm going to get in this query, if you're understanding what's going on, I'm going to be getting a result set that's going to provide me with information about how much money I have wrapped up in inventory for each of the major categories of items that I sell. Okay, so I'll let you look at that for just a quick second and then execute the query. And there we have it. And these then again reflect numbers that are suggestive of the amount of money tied up, for instance, in seafood. Okay, and again, what's interesting here is I don't have to just, find the sum of values down a column. I can actually derive a whole new value and find the sum of that. All right, so let's see what's next here. What's next is that same query where I get rid of those rows that maybe aren't so important to me at the bottom that had inventory values of 0. And okay, so we're using our friend the having clause again here, okay, and it's going to only give me output for rows within this inner join where units in stock are greater than 0. And again, all that's doing is just kind of getting rid of that clutter at the bottom. And somehow, some way I've made a mistake. I don't know what it is. Incorrect syntax near the keyword having. Let's see what I've done. Try it again. There it is. Don't know what it was. Okay, so there's the output, and that's what I had previously described. And let's see if there's anything else here. Yeah, might as well demonstrate this one as well. And this one is going to use the having clause in a different way. Okay, so what do we have? Well, we have the same two columns being projected that result from an inner join between the same two tables, and we're going to be grouping it by category name. Same thing we had before, except this time we're going to filter that result set so that it only selects rows where the category name begins with C. So I anticipate the same output I get here, but only displaying condiments. Make a mental note of that value, and confections, because I'm using this like operator with a wildcard. So one's going to begin with 12, one's going to begin with 10 when I execute. One begins with 12, one begins with 10. Okay, so leave that there for a second. And that pretty much concludes everything that I wanted to cover in regards to aggregate functions as they can be used with the group by and the having clauses.